So let's start with q squared. Can you guys tell me how to set up q squared? 25 divided by, what'd you get? Yeah, 0.06, which is 6% of the population. Bless you. 0.06. And we all have to agree to go with 0.06, because then we're going to take the 0.06 to the next step. So everybody agree on 0.06? Yes, okay. And then how do we get q out of that? Square root of 0.06. What's the square root of 0.06? 0.24? 0.24? Okay, and then what do we do with that? Subtract it from 1. So P is 0.76. Okay, now I need to square 0.76. What's 0.76 squared? 0.58. So 58% of the population is dominant, homozygous dominant, excuse me. And then we got 2 times 0.76 times 0.24. What's the answer to that? 0.36. So 36% of the population is heterozygous. And again, I just left all of my answers in decimal form. You could convert them to percentages if you like. Everybody okay on that, Hardy-Weinberg? It's not hard. Okay, great. I've got 2 more things to talk to you about. So the other day I was telling you about the ship channel. Y'all remember my stories? Told you stories? Okay, so I hope you realize this. We had to dig out the bay to make the ship channel. So there was a whole lot of dirt. So we had to put it somewhere. So they piled it up out in the bay. And they made islands. And they're called Dredge Islands. And I don't know if you've ever been out in the bay. There's islands out there. And they were not there before. We made them. Okay, so I've been out there, and they're now populated. There's all kinds of life on those islands. But imagine in 1900 to 1910 we were making those islands. They were just piles of dirt out in the bay. Okay, so there were these 2 lizards. There was a male and a female, and they were hanging out. It's a story. They were hanging out at Sylvan Beach. They were sunning themselves on this little piece of wood. A big ship went by. And I don't know if you've ever been at Sylvan Beach or even on the bay when a big ship goes by. It creates big waves because of the displacement of the water. So they didn't know. They're just 2 lizards hanging out. And so the wave came in, grabbed the piece of wood, and took it out to the bay. So the poor little lizards are hanging on the piece of wood. And it floats and it floats, and it finally makes it to one of the Dredge Islands. So the lizards are going to jump off that piece of wood onto the island because by then they're just scared to death. They're just, freaking out, okay? They jump off, and now they're on an island. Well, they're stuck there now. So they don't have any choice. They have to mate and have offspring, okay? Because it's a boy and a girl. They like hanging out. So they mate and they have offspring. Well, if you come back 10 years later, you're going to have a population of lizards. All from the original 2 lizards that accidentally floated over to that island. Now, what is that? That's the founder effect. Are you okay on that? The genetics of those lizards were determined by the first 2 lizards that started that island population. Okay. Well, not this winter, but some winters it gets cold around here. What didn't happen this year? And so some of the lizards freeze, but some of them don't. And the survivors set the genetics for the next generation. What do you call that? That's a bottleneck. So you're okay on the difference between founder effect and bottleneck. Okay, great. And then lastly, I need some things that cause natural selection. And I'm going to get us started with something easy. Predators. Don't predators cause natural selection? Yes. Sure. That's why so many things are camouflaged, or that's why so many things are fast, or that's why so many things only come out at night. That's because of predation. So help me add to that list. What else causes natural selection? Climate. Changes in climate. That's good. Disease. That's a huge one. Okay, changes in the climate, disasters, sure. Those are all excellent examples of selection pressures. Things that kind of push a population one way or another. But overall, the effect is that the population, if it's under the influence of natural selection, the population becomes better adapted to this particular environment. Maybe that particular environment now has a new disease in it. Or maybe that particular environment has a new predator in it. But the population becomes adapted to that new environment. It's okay on that. Okay, super. So, our